Alright, here we go with the Game Engine 2 Milestone 1. This is Matthew Erickson's project on this. I'm going to talk about the file converter first, or model converter, whatever you want to call it. What I have open here is the engine folder where I will be storing the models. As you can see, none of the models are here yet. The cube models from last semester. And then I do have a backup of all my models, but it's not going to touch that. That's just in case something goes wrong, which it shouldn't. And then here is where the models are currently. Delete these old ones just so we can make sure it actually does what it's supposed to do. And then we have, the FBXs in here, all the different ones that we might need. And we've got our batch file right here and our exe file with any other txts or whatever needs to be made. We have our batch file here. It's got the conversion for the 5 different models we need to do. And then I'm just using the robocopy to copy them over so that they're actually in the engine folder where I'm storing all the models. For this one, I'm having it go to that converted models file folder first here, and then the models folder later, just as a kind of a debug method, just so I can know what exactly is going on. Is it can't find that folder, or if it couldn't actually do something else. And it seems to be working pretty well. So, getting into the actual code and how it works, we've got a chunk header for each of the different chunks. That's going to have a type, which is up here. Should be the ones just from PA1 or whatever the first assignment was, where we did this pretty much same thing. And then I added a couple of types that I might need. And we've got that, the name, size, and the hash number that we were making. The STL for the FBX vertexes. And then, oh yeah, that's the bounding sphere, which we can go over that quick. So the spheres, we're going to really just store the central point and the radius, and then there's just a function called Ritter's sphere that finds the points. It gets the 2 most distance points that it can. Creates a sphere from there, and then grows the sphere as need be, and this is done in the model converter so that we don't have to do that full process later. Like we were talking about in class, the more offline the better. So yeah, it does that. Getting into the actual writing and reading. Okay, yeah, so we got it getting its points, putting them where they need to go, texture buffer, grabbing the data for all the textures that are linked inside the file, and then we open up our file we're going to write to, and pretty much what we do is we create a chunk header for each chunk that we want to do, so the verts, the tries, the sphere, and the different textures. I got it set up so it can do more than one, but I think the only one that has a second texture linked, I don't know if any of the models we're using actually does, because I think the Warbear, it's not linked even though it can still use it. But yeah, so we can use that and go over to our batch file, run that quick, let it take its time and do what it needs to do. I'm looking for, yeah, here we are. While it runs, I will get the different folders up that are going to have stuff in them. So we can see here, as it creates the models, they start to appear here. And it looks like it's got one left. And having run this, I can see why this would be something you'd want to do offline and stuff like that. Alright, so we can see here that all three of our models have been created, placed in the converted models folder, and hey, look at that, they were also copied over to our models folder inside of the engine. So with that, we're going to switch over to the engine, which is right here. In here I have a class that specifically loads models from files, taking in the file names, which are the ones we just created. And if I can pull that open, where are my models at? Here they are, file loaded H and CPP. So in here, basically there's a structure that creates the sphere, that's all we need for that. And then as you create one, it'll go through inside of the constructor and get all the things it needs, and we can get our bounding sphere data that's being stored here, or find different chunks, whatever we need. If we go look at the CPP, we've got our private VAO used for sending data to the graphics card. File load. Yeah, we know that one. Oh, okay, so the loading from the file is actually done up here too. Yeah, there it is. So we have it go through and grab the vert first, the tris, and the sphere. And then we can get the center and the radius. We'll just plug it into those two. And oh yeah, here's the finding the chunk that you might need formula or function that just goes through and says, hey, well, this isn't null. Go through until you find the one that you're looking at or you're looking for. So with that out of the way, manager game objects, we want this one. Here we are. We've got our cameras, different textures, different shaders, and then yeah, here we go, the actual creation of the models. As you can see, it really didn't change much. All I did was add in, so you pass in the model that was loaded, the textures, and then you can set your position, your scale, and your rotation. For this is just a static rotation. Some of the models weren't facing forward, and I wanted them to be facing forward, so I added that in. And then I added in 3 other variables, a delta trans, a min trans, and a max trans. That's just how far it'll move. This will just let the models move back and forth on their own. Basically all this does is just so we can check the bounding spheres, whether they're changing colors or not, which is the next thing that we add to, after we add it to this is adding the first model into the game object manager. Then we go through and get our sphere model and make that a game object, and then we get the bounding sphere from the first model, set the position, set the scale, and then we add it just as a child of the first game object there. This one's just just a child, so it'll move along with it. The position and scale are both local in this case instead of what's the word for it? Instead of world. Sorry. So we do that for all of our different models. We've got the Astro Boy, the ship, War Bear number 1. Don't remember if this is the... Oh, okay. This is the brown War Bear, the buggy, the polar bear, and then my custom model, which was gotten just from the common folder. I take no credit for that model. And then we also have the model for the camera model that just gets set up, and I believe at the top, yeah, right here I set it all up to draw in green. And if we scroll down, I think that's all I needed to do for that. So if we check it here and let it run, you can see that all the models are drawing and moving back and forth. Obviously none of them are turning red that we can see right now because this is the camera we're checking against, so if you can't see them, you can't see it go red. We can jump to the other camera, and at this angle you can see that some of the models turned red depending on if they're inside or outside of the camera. The view area. And so that's pretty much it. You can see that they're all different, turning red depending on where they are, whether they go out the right side or the left side or the front side or the bottom side. I think when I drew this, I have it going way too far back, so it doesn't. None of them quite make it out the back, but it would work the same way. Yeah. So that's my project for the Milestone 1, and thank you.